Hello, welcome for our next science lesson. In the previous lesson, we have been looking at the global issues. And on the global issues, we found out the various debates in science and society. Those debates have been of vital importance to enlighten us, so as we are able to understand that as much as we are involved in science, technology, innovations, and various changes, we learn that after discovering any change over science, these changes are bringing issues that are affecting everyone. They affect the society. They also affect the economy of a given country. We also found out that science alone cannot provide answers. Why? Because science and technology is really improving, and every time it improves, there are dramatic changes that occur also in the society. As often as you know, some of these changes are termed or are viewed as very positive changes. Others are found out and they are discovered to be negative. Therefore, after looking at those various areas of debates, such as human being involved in the global climate change, the nuclear power plants, should they be built in Australia, clean coal and gaseous centration technology that it traps the carbon dioxide underground, can it also be developed? We also looked at the other part as, is it appropriate to transplant organ from other species of an animal into human system, a process known as xenoplantation? Should we also adopt genetically modified crops, in our country? And what are the evidences required? Among other areas of discussion, we also able to look at the cost and the benefits of those changes as much as they accrue on the global issue. We also found out that among all these changes, as much as we have to bear the cost, one of the costs that will help us to make economic improvement is to understand the triple bottom line of all this matter. And we summarized them and found out that all this has a good argument for the calculations and of the company's triple bottom line, which is adding up all the benefits and the costs in its activities that are much culminated in the terms of economic, the impact to the environment, that is the natural environment, and eventually the impact on the general society, clearing out with the values and the ethics in the society. Okay, when we look at today, continuation of the same global issue, we are going to find out the nuclear power in Australia. Nuclear power in Australia. As you discover out, be able to learn, do we have nuclear exploitation in Australia? That is my questions. We have to ponder on it and come up with the relevant arguments about it. But now, how is nuclear power developed in Australia? Has it been adopted? Nuclear, first of all, we have to understand what is nuclear energy or nuclear power. Nuclear energy is obtained from the nucleus of an atom. We learn that nuclear energy is obtained Nuclear energy is obtained from the nucleus of an atom. From the nucleus of an atom. I hope up to this level you understand what's an atom. And it is obtained from an atom through various processes. There are two main processes that are involved here. And these two processes are the fission and fission. Through fission processes, and also the second one is fusion. That is why we are going to exploit it. Okay, in radioactivity, we learned that there is a constant reaction of atoms and nucleus. And we learned that there are two processes of reaction that takes place. Therefore, these reactions are the fission reaction and the fusion reaction, or the rate of fusion. It is very much important to know that nuclear energy is obtained from the nucleus of an atom through fission and also fusion. Nuclear fusion produces energy that can generate steam. Like us clearly to understand and be very much categorical. Nuclear fission produces energy. This one produces energy that can generate steam. This energy can generate steam and turn the turbines, and turn the turbines. It actually turns the turbines. These turbines are the ones that are responsible to produce electricity. Therefore, nuclear fission produces energy that can be used to generate steam, and then this steam is the one that is used to turn the turbine so as to produce electricity. It is very, very much important when we look at it categorically and specifically in this manner. And all of the today's plants, they use fission to generate their electricity. Remember, after looking at the energy resources, you will find that there is a high demand. There is a high demand of energy in every sector, in every industry. And as a result of this, it is important for the given industries or given sectors to develop alternative sources of energy to meet their daily demands. Because as time elapses or as time goes throughout, there is an ever-increasing demand of energy to propel our machines, to propel our industry, to propel sometime our vehicle, and whatever we need is just energy. Also, the common fuel that is majorly used in fission is uranium. Uranium becomes the common fuel that is used. The common fuel that is used is uranium, The common fuel that is used is uranium, although there are some additional elements that could also be used in place of uranium, such as thorium. It is either uranium or thorium. These minerals plays an important part in what we call nuclear fission. Because of this reaction of the nuclear fissions, we'll find that uranium becomes a common fuel that is used. It is like a catalyst, or maybe thorium, so that the rate of reaction will be very fast, and then in producing or generating electricity with a maximum megatonnage. Nuclear fusion, when we look at the nuclear fusion, it is somehow different from the other, but nearly the same. While nuclear fusion is a reaction in which two or more atomic nuclei are involved. This one is a reaction in which it is simply a reaction in which two or more atomic nuclei collide. There is an atomic nuclei. When these atomic nuclei, they collide, what happens? They collide at a very high speed. They collide at a very high speed and joins again. Therefore, what happens as it joins again? During this process, matter is not conserved, because some of the matter of fusing nuclei is converted into photons, which produces very enormous energy. You will discover that during this process, matter is not conserved, because some of the matter of fusing nuclei are converted. These matters are converted into photons. They are converted into photons. It is these photons are the one that produces energy, which can be used in various places. This energy could be very much usable. When we go back in the history of the Australian nation, around in the year 1970s, that is in 1970s, that is to around 1980s. What happens during this time? Nuclear issue seemed to be very clear. Nuclear power had a potentially dangerous number of accidents at the nuclear power plants. Their background was actually not good. Why? Because they perceived they perceived that nuclear power had potentially dangerous accidents, had potential dangerous accidents, Most of these accidents were appearing at the nuclear power plant. These nuclear power plants were the areas where most of the accidents had been, and this created, as a result of that perception, anyway, the accident could occur. As they occur, those accidents, you will find out that they created the radioactive wastes. The radioactive wastes which needed to be stored safely for thousands of years. These wastes needed actually to be stored safely. They needed to be stored safely for 1,000 years. Why? When we come to the radioactive wastes, some of these wastes have devastating effects, especially when they are not stored well and properly. Why? Because the radioactive elements themselves, they produces some other effect now on the society, to the people and the environment. This has brought a problem over the years, and therefore many countries, such including Australia, as a result of those threats and those negative impact, because just you need to store these elements or the wastes for 1,000 years very safe, then you could be able to have incurred a lot of costs. How can you store a waste for over 1,000 years? In fact, that means over your lifespan. It is a lifespan of around 3 to 4 generations almost. These generations are the ones that are going to suffer. Therefore, when these people in the society are exposed to this radioactive waste, first of all, the natural environment itself is degraded. There are some harmful effects. I told you that radioactive elements, they work on the genetic or the DNA of individuals, and therefore producing what you call abnormal growth among the human life. As a result of that also, as it stays in the environment, there are some degrading or hazardous effects that could be felt. Once again, if you want to store this waste safely so that it does not have an effect, should be for 1,000 years, so that their half-life have been reduced to 0. That rate of fusion require enormous. And although it is positive, in other words, to produce a lot of energy, these wastes have an impact to the society, to the individual, and again to the economy, because if the energetic people in the economy are going to be affected by these radioactive wastes, where do you think the economy will grow? It becomes redundant. And as a result of that, the debate, after realizing that in these early years, many countries, including Australia, they resolved, many countries, including Australia, resolved not to invest in nuclear power. They actually resolved not to invest in it. And as a result of that, at least there are some safety measures that have been taken into consideration before this is brought to the limelight. It is only in the recent years, especially this year and maybe the few months ago, there has been debates and discussion about the nuclear power. And it has been touching the whole world, including the South Korea and the Northern Korea. Australia is also involved to a given area. But in this judgment, it was not this judgment, it was just a judgment that was made against some given background from the Australian or the Aboriginal people. This judgment was made against, it was made against a background, it was made against a given background, and this background is very much important for us to exploit. A background of there was an abundant, cheap fossil fuel, that is fossil fuel. The cheap fossil fuel such as coal and oil. These were already existing in Australia. And as a result of having coal and oil, the Australian government or Australian community resolved not to invest in nuclear power until of recent. As a result of that, they only understood that the nuclear power has hazardous effects and degrading, harmful effect on the environment. This brought a very, very devastating judgment to these people. But when we look at the judgment and weigh the two of them, you'll find that it is seemed to be less dangerous and have less environmental cost, especially on choosing coal and oil. They found out that coal and oil is less dangerous on its exploration. It is also less harmful to the environment on its operation. It was less harmful on the environment on its operation. Therefore, as a result of that, they delayed to invest in nuclear power. But more of the recent discovery, however, it has been realized that thousands and thousands of people, they are still dying. Thousands and thousands of people are still dying, even in the mining of coal and exploration of oil. The people are prone to accidents. Therefore, more lives and accidents have been found out that they are occurring in the mining of coal. In the mining of coal. And also another effect that has been also realized later, mining of coal has its effect on the environment. It's dangerous. Coal has effect on the environment. Why? For it produces pollutants. There are some pollutants that are being produced as a result of mining and bringing out energy out of coal. These pollutants include mercury, given a chemical symbol of Hg, and also another pollutant that is also resultant and very dangerous on the environment, because as it goes and decolorizes, it produces what we call an acid rain. These two have been found out that they have a devastating effect, especially mercury and acid rain. Both of them work on the environment and also human. More importantly, the fossil fuel have been found out they only release the greenhouse gases such as the carbon dioxide, which has been recognized as an important and a social scientific issue in the global world, therefore leading to the production of the global issue. It is in the production of the global issue. Production of the global issue. Therefore, that one has become a challenge. But today, the nuclear power plants is accounting for a given percentage. Before we look on that, it is also good to look at what is the nuclear power rate or percentage of the nuclear power globally, because it's a global issue. Today, nuclear power plants have been built up by various countries. They are actually producing electricity. They account for only 11% of the global electricity that is needed. Now, this electricity which is needed in the global generation, it has got a generation of about 80%, generation of about 80%, that is instituted capacity of being in the OECD. That is the countries that have a capacity of producing nuclear power. All this capacity is rated in nuclear fission. And it has been an attempt of various countries now, having that now we have an alternative source of energy that is now coming on the nuclear power. Only 11% is accounted for in the world. And so far, although the argument and the perception was negative from various countries about its hazardous effect and impact on the environment and the people, still some countries have made risks to invest in nuclear power so that it's seen that when they avoid the fossil fuel, when they avoid fossil fuel, they are doing less harm to the environment, and therefore seemingly they think that they are reducing the rate of global warming. We shall be able to look at it. The rate of global warming. When they look at it in these three perspectives, when they avoid excessive use of the fossil fuel, they have less harm to the environment, which is also reducing the rate of the global warming. And as a result of this, nuclear energy through fusion, we find out it is releasing 1 million times more than the fossil fuel. In the same perspective, we realize that nuclear through fission, it releases several megatons. This can release, it is very important to note that this can release 1 million times. 1 million times energy. More per atom. That is energy. That is more per atom. Every atom that has been involved in the reaction, when we compare with it than the fossil fuel, when we make this comparison, we'll find out that this reaction produces and releases 1 million times of more of the energy per given atom, and when we compare it with the fossil fuel, it is now 1 million times more. This can also be integrated into electricity grids, which is currently utilizing the fossil fuel. But we have still to make some advancement in this field. For example, when we look at the various repercussion of the production of this energy, you will find out that now, because 1,000,000 times more that is produced in every atom, especially that is happening in nuclear fission, when we compare than those atoms that are found in the fossil fuel, the formation of fossil fuel takes longer period, several years, several decades to be formed, especially coal. When we also move to the oil, it takes various periods to be formed. For example, when we bring down the formation of this fossil fuel, just in a demonstration, from the word fossil itself, we are able to learn that these are the materials that are obtained from dead plants and animals. When these materials are laid down in strata, or stratum, they are decomposed. They are decomposed and lithified. They are decomposed and lithified. In the process of lithification, you will discover that several layers are going to be laid in various parts. This is simply a demonstration of those layers. And then, because it meets an impervious rocks, there is an impervious rock, then we will have something developing into the fossil, and it takes very long period of time to be formed in this manner. The formation may take longer time as a result of these atoms undergoing decomposition, and the same decomposition continues, so that the materials are laid down in strata, and after being laid down in strata, decomposition again occurs. When this decomposition occurs, it produces what we call natural gas. Therefore, we will have a column of natural gas here. We'll have natural gas that has been formed, and then after the natural gas, this layer is a layer of water to some given level, and then oil is found in this way. Therefore, it is when the dead plants and animals occur so that the fossils can be formed, actually it depends on the maturity sometime, or just simply this life must be there, the life of plants and animals. They must also be laid down in stratum so that they are sedimented and again decomposed and lithified. In the process, now after a period of time, sometimes it may take 10 million years. This is a longer period for the formation of natural gas. We'll have a basement of water, and maybe oil, layers of oil along the surface as it is. This is on the underground. You'll find out that it takes period of time, unlike when we just move direct to the nuclear power. Just the reaction of fission, these atoms, we bring them together. When they react, immediately there is an instant release of energy. But when we go to the fossils dependent, we'll discover that fossils really takes a lot of time. And as a period of time for them to be formed, it will also involve technological ability and advancement to make what we call exploration. This exploration may be to study and find out whether it is viable enough to explore that particular oil or coal. Is it present in particular region? And also we invest a lot of capital and some skills that are important, needed, and they are required here. Calculating all the period of formation, the skills required, the formation, and some other benefits and disadvantages that may accrue in the fossil fuel, you will find out that it is very, very exorbitantly high. And that one makes different countries, different people to think about alternative of having dependent on the fossil fuel. Therefore, the nuclear energy through fissions, understand that it produces 1,000,000 times more energy per atom than the fossils. If you bring the two comparisons into the limelight, you will discover that it can also be integrated into electricity and can be graded or can be embedded in electric grids, which is currently needed. Then we have to move again and see. The nuclear has a large power generating capacity. That one is a fact. Nuclear has, or nuclear fission has a large capacity to generate energy. There is a high capacity or very large capacity in generating energy, and actually has low operating cost. That is a point that we are moving on to, making it very much ideal. Making this one very much ideal. It becomes very much ideal for base load generation of energy. That is for base load generation of energy. Yes, it becomes very much important in this manner. When you compare the two, the capacity of nuclear fission has actually a very large capacity to generate energy, and it has also low operating costs. It is actually a low operating cost. This low operating cost make it very much ideal for base generation of energy in large consumption. though its initial, only we have to know that its initial capital is intensive, and the present financial risks to the investors, it gives them a lot, and the extent of time frame, the power plants must be in operation to recuperate their costs. That becomes a very significant part that we have to understand. Then, more so, nuclear energy does not emit greenhouse gas. Nuclear energy does not emit, this one does not emit what we call the greenhouse gas. It does not emit greenhouse gas, and therefore, for this reason, it is often seen as a substitute for the fossil fuel or fossil energy generation, and it becomes a solution for mitigating the climate change. However, nuclear fission has a variety of environmental effects and health issues associated with it. Out of all of it, it is important we foresee, and let us just use an example of some megatons. Some megatons, so that we find out what happens on the effect of the nuclear energy on the charts. When we look at the nuclear devastation, it is a sample of the effect of nuclear blasts. This one is from the nuclear blasts, and as we look at it, the predicted devastation of 20 megatons nuclear blast is described in the table that we are going to look at it. 20 megatons are involved here. When we look at the effect of the nuclear blast, there are 20 megatons, and this one is equivalent to 20 million tons. That are produced in a given blast, that is of TNT explosive, when we bring them to TNT explosive. Therefore, on a single explosion, regarding of the distance, there is a 20 megatons that are produced, and that is an explosion or that occurs once in a nuclear blast. When we look at it, this one gives us the distance from the explosion, where we can say that is explosive explosion of town X, for example, which is 3.2 kilometers away. What is its effect? We look at its effect on the environment, on the sometime economy, and also on the life. We'll find that all people are killed by radiation. All people in this distance, just staying on a nearby distance of around 3.2 kilometers, the effect is that they are going to be killed by radiation. And that is what makes the explosion to have happened in this simple way. What also happened to the environment? All buildings are flattened in a distance of 3.2 kilometers. It is actually indeed devastating. Why? There is also a traveling speed of the wind comes to 3,000 kilometers per hour. That now means that there is a looming effect still on the environment. And again, let us look at a different area where we can have the nuclear blasting. If we have a nuclear blast in a distance of around 8 kilometers away from the explosion, people are going to be killed by the flying debris. We'll find out that the flying debris are the ones that are going to kill the people. And then we'll have on the environment, there will be a moving wind speed of 700 kilometers per hour. Does that one makes a devastating effect on the environment? Look here also, in a distance from the explosion of 16 kilometers, we'll find that people will have broken bones. There will be ruptured eardrums, and most houses will still be flattened. These are the effects. Now, if bones are going to be broken, and then the eardrums are ruptured, the eardrums are ruptured, what will you use here? Bones are broken, and it is actually a distance over 16 kilometers away from the explosion. That could be a given town, such as the in Australia we have the Black Town. We also have Marlborough Town. That is where we propose the nuclear power plants to be found. The effect will radiate, will travel this distance. We have been able to find out the distance. 16 kilometers, the broken bones of human beings, animals, the eardrums of both human beings and animals are going to be ruptured. And then most houses will be flattened. What about an explosion or a nuclear blast that occurs from a distance of 32 kilometers? Many of the houses are the ones that are going to be destroyed, and therefore there will be a looming speed of wind of around 120 kilometers per hour. When we look at this means nuclear plants should be situated away. Nuclear plants should be actually be situated away from human. At least distance not limited to this should be now around 40 kilometers and above. When we have just to locate one nuclear plant, we will be carrying out our nuclear blast for the purpose of production of energy. And also in the same way, it is important the radioactive wastes. It is important for the radioactive wastes. The radioactive wastes, these radioactive wastes be stored safely. Be stored safely. When the radioactive wastes are stored safely, we are trying to avoid the harmful effect and the danger that is associated with it. And then we have to look at it in this angle. What also does it mean? What also does it mean? We also have to learn to avoid coming in contact with this radioactive waste. Avoid the contact. Of these radioactive wastes materials. For the safety of human and also somewhere on the environment. For the safety of human and somewhere on the environment. That brings us to a very comprehensive understanding of this. Therefore, nuclear energy does not always emit greenhouse gases alone, and it has become a substitute solution for the fossil energy. Therefore, we need to try to invest in it. However, we also have to understand there are some devastating effects on the health issues which are associated on it. Could you please outline some effects of the nuclear power generation? Outline some few of them so that we are able to understand the concept of the nuclear power, even as we make risks of going to develop them and produce energy for our industries. It will be very important that nuclear plants, they should be situated at least away from human, and also those blasting regions should be kept safe, and the radioactive waste must be safely stored, and also human beings avoid the contact of the radioactive wastes for their safety. It is more important. Have a good day. Thank you. We shall continue in the next lesson.